Okay, we're going to talk a little bit about BIOS and UEFI. It is the operating system um, that runs the show before the operating system does. So it's your firmware OS, to think of it that way. Right, so there's two different systems you're going to encounter. One is BIOS, Basic Input Output System, and the other one's UEFI. Unified Extensible Firmware Interface. Why did they make it more complicated? Because it is more complicated. The UEFI, unlike BIOS, is extensible, meaning it's expandable. It can do a little bit more, well, quite a bit more than BIOS can. BIOS was your basic input-output system. Hey, you got a keyboard? Great. Here's what date and time it is. Terrific. Here's the hardware that we recognize on it, and that's it. You want to enable or disable it. Done. UEFI can now do a whole bunch of other things, and it's a standard more than it is a thing, and a consortium of technology companies came together and said, hey, we need this new standard to allow us to interface with our hardware a little bit better, and they came up with UEFI. Right. Firmware, for those of you who don't recognize that term, it's software that's integrated into a chip or set of chips. It's non-volatile, meaning when you turn your machine off, firmware is still there, right? Where's that firmware stored? It's stored for BIOS and the UEFI. The firmware is stored in the CMOS chip. CMOS stands for Complementary Metal Oxide Semiconductor. It's important that you understand that CMOS is an object on your motherboard, because there is also what's known as a CMOS battery. The advantage of metal oxide semiconductors is that they can operate at very low power levels. They require very little voltage. So we can keep information in them providing we provide enough current, enough voltage. So we rely on a 3-volt CMOS battery to do that when the machine is unplugged or turned off. Right? This is how your computer can remember the date and time correctly, even though you haven't had it plugged in weeks. You put a computer in storage, pull it out, it'll still know what date and time it is, provided that CMOS battery is still functioning. It allows transient information to be stored inside the CMOS. It's not required for the firmware itself, but it is required for any data that you store there. For example, preferences, settings, enable disable devices, date and time. Those are all stored in your CMOS, right? These integrated circuits, like I said, they contain the firmware, right? And either BIOS or UEFI, what we use or what we see, the user interface we see, is that firmware. So we can usually access that interface using a hotkey. For the most part, it's things like F2, a function key, or the delete key. Those are the predominant ones. I've seen key combinations, Control Delete, F12. There's a number of different hotkeys. Be warned though, different functions, when we talk about disks and we talk about RAID arrays, right? They'll use function keys to access their firmware as well. It's a little different. So what you have to do is read that splash screen that comes up. That splash screen is going to tell you, hey, hit F2 to access the user configuration, the system configuration. That's the BIOS. The motherboard manufacturer determines what the hotkey is, but predominantly are F2 and delete, though you just got to watch. The difference between do-it-yourself products, what we call white boxes, boxes you build from the motherboard up, and commercial products like Dell and HP and Alienware, is what is accessible through the firmware. One of the big differences typically is what's called secure boot. Secure boot in a commercial product like a Dell is automatically enabled, and your ability to go in and change that setting is disabled. You won't see it in the UEFI or the BIOS. Well, secure boot doesn't exist in BIOS, it only exists in UEFI. So you won't see secure boot in a UEFI of a Dell laptop, typically, right? You will, however, see it in a white box or one you buy the components for and put it together. When you buy the motherboard straight from the motherboard manufacturer, they don't filter out the UEFI. They don't put any restrictions on it. You can get right down to whatever the nitty-gritty is that they have in there. Secure boot is one of those options. Now what secure boot does It makes sure that the drivers and software that's running on that machine is licensed or authorized. It prevents malware from running or posing as a graphics driver and infecting your machine. So Secure Boot protects your machine, though some say it limits it. It is your own protection. The nice thing about a do-it-yourself product is you decide whether or not you want to be protected, right? So it's a play at your own risk thing if you turn Secure Boot off, right? Got to be extra careful and extra vigilant since the firmware isn't being vigilant for you, right? The other difference is granular control, right? How much control you get over the components and the operation of the hardware on that machine. Specifically, or one example of, is OC, or overclocking. Overclocking is a method by which you can increase the cycles per second, remember those, by increasing the voltage that's passing through a chip or set of chips, so your RAM or your CPU. So typically we refer to overclocking as CPU, but you can overclock your RAM as well. So what that really does is it increases voltage, right? You'll understand why some manufacturers don't like doing that. It tends to burn out components. So if you have a 1-year parts warranty and you allow your users to OC it, right? Well, guess what? They're going to burn up the RAM, they're going to burn up the CPU, then they can turn back around at you and say, hey, you gave me a 1-year warranty and it's no longer working. So they tend to disable overclocking on a commercial product. On a straight product, yeah, nope, go right ahead. You want to burn it out? Go ahead. We're only giving you a 90-day warranty anyway. We don't care. And if you do burn it out and you say, well, my processor has a lifetime warranty, it does at normal levels of operation. You OC it, they're going to know when you send it back, and yes, they're going to want it back to see. Right? So do-it-yourself products or motherboards purchased right from the manufacturer tend to have a little bit more access, a little bit more granular control. So now what I'm going to do is flip over to a tour of an example of a UEFI. I only have one for you. I can't show you them all because every motherboard has a slightly different UEFI because there's different hardware and software running on them. So I'm going to show you one, just give you a quick tour of it, and then I'm going to turn you loose on 2 different BIOS UEFIs out in the lab. Okay? All right, so here is your basic UEFI tour. Right? Down in the right-hand corner, at least in this ASRock motherboard, is a message, and I know it's hard to read on the screen, that says press F2 or delete to enter user setup. And so that's what I'm going to do, or system setup. So once you hit F2 or delete, boom, there you go. That's your hotkey. It differs, the message differs in location depending on your motherboard, and what the key is differs. But again, F2 delete tends to be the key you hit. Once you do that, the BIOS, or in this case UEFI, will launch, and there's your interface. Now this particular interface goes into the advanced menu right away, but if we switch back over to the main in this UEFI tells me a little bit about the device, right? What processor I'm running, what the frequency of the processor is, where the memory is installed, how much memory I have, the basic nitty-gritty of the device. If I go over to the next menu, the OC, that's your overclocking. We're not going to spend a lot of time there. We're not overclocking these things. And in the advanced menu, here's where you get to drill down into what your machine has and what it's capable of doing and what your options are. So if you look at the advanced storage configuration there, I'm seeing my serial ATA drives. They're set up in RAID mode. We'll talk about RAID a little bit later. It's just an array of disks. And hot plug. Can I swap a drive out while it's on? Not in this device. It is currently disabled. So that's here. It's giving me a little bit more detail about specifically the hardware manufacturers of the drives. So you'll see there's an SSD and 2 regular magnetic drives. If we go over to the security, here's where your secure boot is. So right now, notice that secure boot is disabled. I am the one who needs to police it, right? So my secure boot is disabled. That means it's not checking for authorized drivers and authorized software. It's letting me run whatever I want to run on it, which is both problematic and fun. Right? Here are my boot options, right? So on boot, what operating system, if I have multiples, I'm going to boot from. Down here, we'll see whether the the num lock is on or not upon boot up, whether I want the boot beep. The boot beep is your post beep, power on self-test beep. If the beep is turned on, I'm able to hear an audible sound. If I have a speaker installed, I'm able to hear an audible sound on the device, letting me know that all the hardware checked out. If it doesn't check out, there'll be a beep code, right? I'll have to look up what that beep code is for every motherboard. You'll also notice here where the cursor or where the highlighted portion is, that's my setup timeout. It was originally set to 1 second, so it gave me 1 second to hit the F2 key. That's great if that's the key I know, if I know it's going to be the F2 key. It's not so great if it's a new machine. So here I'm changing it to 5, so it gives me a little bit more time to hit. Normally I leave it set at 1, but for the purposes of, this demonstration, I'll set it to 5. That gives me a little bit more time to hit the F2 key. Once I'm done fiddling with all the options I want to fiddle with, I want to make sure I exit. But exiting isn't just exiting, I also have to save these settings. So I'm going to save changes and exit and say yes. Once I do that, the device basically reboots, it applies those settings, and it's going to take me to my operating system. So you'll see the message for the F2 come up again. There it is in the bottom right-hand corner. I don't want to enter BIOS or UEFI again, so I'm going to let it boot to the OS, and I'm good to go. Those save and exits, right? That's where the CMOS battery comes in. Without that save and exit, without that battery, those settings wouldn't be retained. They'd be blank options, right? So the CMOS battery allows us to make those changes and save them long term, even though the PC is unplugged or turned off, right? So that's one example of a UEFI interface. They're going to all look a little different. Sometimes it takes research. Sometimes it takes actually reading the manual that came with the motherboard to know where to find all of the options. Experience is the best teacher. All right, so now I'll turn you loose on the activity, and if you have any questions, you know where I am.